Hello students, in this video I'll tell you how to time your Java code, and by time I mean you can measure time taken or time elapsed for a particular code segment to execute. Now this time will be measured in nanoseconds, and this will enable you to compare different methods of doing the same thing. So without further ado, let's begin. So what we'll do is, first I'll take a class because it is necessary to take a class in Java. So I'll call it class measure time, and then we'll have our main method. Now in order to time something, we should have something to do. So let's say I take a small code segment to find the number of digits in a number. So let's say I have an integer which is storing some number, let's say 1 2 3 4 5 6 7 8 9, and I want to count the number of digits contained in it. So we'll use the usual method. I'll take a loop, we'll create a variable temp, we'll say temp is equal to n, and while temp is more than 0, we'll keep on dividing it by 10, and then within the loop we'll take a counter and we'll find the sum. So we'll just say int count is equal to 0, and then within the loop I'll say count plus plus. So this loop is basically running for the number of digits time, and we are eliminating one digit at a time, and our counter is going up. And when everything is done, we'll say system.out.println, and we'll give our answer, that is count. Or let's give a message also. I'll say number of digits, and then we'll display the count. So if I run this program, computer will give us the answer. So let's run it and verify whether the code is working or not. So the code runs and we get the correct number of digits, which is 9. Now our objective is to find out how much time is taken in order to compute the number of digits. So for that, what we'll do is we'll take two variables. We'll call it long, let's say t1 comma t2, and at the point where we want to begin the measurement, we'll say t1 is equal to system.nanotime, and where we want to finish the measurement, we'll say t2 is equal to system.nanotime. Now please understand, this function nanotime returns a time from an arbitrary point from the Java virtual machine. It's not a real time, and it's not even based on the real time. And please understand one more thing, there is a limit to it. If your code segment is taking more than 292 years, this cannot be used. And I believe that that's just too much for most of the practical things which we'll be doing. So we have calculated the two times, one before the code and one after the code which we want to measure. And then what we'll do, we'll simply display the difference. So I'll say system.out.println, and I'll say elapsed time, and then I'll display the value. I'll say t2 minus t1, and then let's say for clarity we also display the unit. Okay, so now if I run the program again, we'll get the time taken to run this loop. We are not trying to calculate the time taken to print the answer. We are only interested in the main part of the loop. So let's run it. So if I run it now, the program runs and it says that it took 2604 nanoseconds. Now the interesting thing is, if I run the program again, now let us run it again, you will not get exactly the same answer. See, this time you are getting 1919. If I again run it, you are getting 1562. If I again run it, you are getting 898. If we again run it, we are getting 3827. If we again run it, we are getting 996 nanoseconds. So how much time it actually takes depends on what other things are going on behind the scenes. Like right now, I'm recording the video, so that is also taking some time. There's a messenger running in the background, that is also taking some time. You might be having a virus scanner running, which will also take some time. So it's better that you take several of these values and then find the average. So basically this is a rough estimate. Don't go by the exact value. So let's run it once more and see what happens. So there you are getting 1601 seconds. So basically the time is hovering around, let's say 2000 nanoseconds or something. Okay, now I said that it is useful in comparing two methods. So let's say, for example, I want to count the digits using another method. So let's say take one more method, and then we'll see whether this method is better or not. So let's take, I'll again take T1 is equal to system dot nano time, because we want to measure from the next line onwards. And then the method is, I'll say that, okay, count is equal to double quotes plus n, and then I say dot length, sorry, dot length. So now this looks like a very neat way of doing it, a very small and a cute little way of doing it. But is it better than the earlier method that we are going to check? So we'll say T2 is equal to system dot nano time, and then as usual, like we did earlier, we'll display the message and we'll display the elapsed time. So the message is again count and the elapsed time is so much. So let's begin the execution, and there you are. So the first method took 2319 nanoseconds and the second method took 56292 nanoseconds. Now if I run it again, you'll get a different value, but the point is the difference, or rather the order of the difference, will more or less remain the same. So if I again run it, see, 2736 19346. If I again run it, so though the actual values are changing, you can still see that the first method is much better than the second method, which is obviously taking too much of time. I think you learned something new today. Thank you.